So again, if you look at page 7, for little factoring review problems, these all contain something in common because they all have the GCF. So the first step of factoring, always think about what do they have in common. And each one of these problems, they all have a GCF, a different GCF, but that would be like the common part of factoring with these. So with letter A, 4x squared minus 4, what would you do to start factoring then? Chris? Yeah, divide it by 4. And if we divide by 4, there we go. We end up with x squared minus 1. So GCF, when they have something in common, you take that out. That's a way of factoring. You place it outside, you put parentheses around it. Is there anything else you can do to factor it? Nick?
The x squared minus 1, x plus 1 is 1.
And why can you do that?
Because x squared minus 1 is the difference of 2 squares.
Yeah, that's a difference of 2 squares. So we have a difference, they're perfect squares because I can take the square root of 1. 1 times 1 is 1. So besides just taking out a 4, we can take the square root of both of these because, as he said, they're perfect squares. And I can factor that as x plus 1, x minus 1. Once your power inside is down to just being an x, you've factored as far as you can go. So x plus 1, x minus 1. But then the 4 also has to be in front. That was the GCF. Questions? So looking at letter B, Jack, what can we do with letter B?
You can take out negative 3y.
Yeah, so we can take out a negative 3y. And what do you get when you take that out, Jack?
Y plus 6.
So when you look inside the parentheses, y plus 6, it's just a y. It's not a y squared. So this is as far as you can factor it, pulling out a GCF, and then there's nothing left for you to do with that problem. Letter C, we have negative 4m squared minus 10m plus 24. Nina, what could we do with letter C?
You can divide by 2.
Divide by a?
Would just be 2.
Yeah, you could do a 2. Because this is negative, you could also do a negative 2. So either way, but generally when we have a first term negative, we pull the negative out with it, but either way it could work. So I'm going to pull out a negative 2. But that's all they have in common. So that would be the GCF. They have a negative 2 in common, nothing else. And then, Nina, if I divide by negative 2, what would you have left?
You have 2m squared plus 5m times 4.
Yeah. And then that would be it for that problem. We can't really take it any further. Pulling out the GCF is still a type of factoring. And then the last one, 5z squared minus 25z plus 40. Dimitri, what can we do with letter D?
Divide everything by 5.
And what do you have left when you divide by 5?
Z squared minus 5z plus 8.
Okay. And then, because this has a 1 in front, Dimitri, are there any two numbers that would multiply to be 8 but add to be negative 5? No? Why not? Are there any ways that 1 and 8 or 2 and 4 can combine to be negative 5? No. Question, gentlemen. We will talk about how to factor that today. So we haven't done any factoring with coefficient. Questions? So if you look underneath, we are going to talk about factoring. This is the AC grouping method. We generally call it the grouping method or the AC method. We are going to factor with coefficients with the x squared. So we have a 5 in front of the x squared, and then a negative 17x and a plus 6. And there are a couple of little steps underneath to kind of get you to think about how to factor this type of problem. So the first one says multiply a times c. What are the a and c values that we're multiplying together? 5 and 6. So a is the first number, c is the last number. These problems are set up in this form of a quadratic that we talked about on Tuesday. So ax squared plus bx plus c. The a is 5, the c is 6. And we're going to multiply those two numbers together. And we get a positive 30. So that's the AC part. We're multiplying a times c. The second step says find the factors of this product AC that add up to the middle value, which is kind of similar as to what we've been doing. So Josh, two numbers that multiply to be positive 30. What could we get to be positive 30? So he said negative 15 and negative 2. So 5 and 6 also make 30, 3 and 10 also make 30. Like those would be the factors that would combine to be 30. 1 and 30 also make 30. But our goal is to add to be the middle number, which is negative 17. And negative 15 and negative 2 combine to be negative 17. So step 3 says to factor by grouping. Does anybody know what you're supposed to do with those two factors?
Don't you plug them in?
We are going to plug them in the problem in some way, yes. But they don't just drop into parentheses like we did before. Not quite, but we'll get there. So we're going to take our original problem and we're going to rewrite it. We're going to rewrite it using these two numbers as factors. So my first piece, that's the a term, says 5x squared. I'm going to keep the 5x squared. The next term was negative 17. And Josh just gave me two ways that I can combine, or two numbers that combine to be negative 17. So I'm going to use those two numbers and change 17. So instead of writing negative 17, I'm going to write negative 15x and negative 2x. Because together, these still make negative 17. So I'm just rewriting the way to have negative 17 in the problem. And then we end with the plus 6. So this still says 5x squared minus 17x plus 6, but it's written in a different way. So we just rewrote it. So the way grouping works is that literally you pair two numbers together. You group two terms together. We're going to put a little bar down the middle after the 15x because those would be my first two terms. These are my third and fourth term. So that's where our grouping goes. So I'm not putting parentheses, I'm just putting a little line down there to separate the problem. You are going to pull out what the first two terms have in common. So this is almost like the GCF method by grouping two things together, grouping two things together. So Emma, what would 5x squared minus 15x have in common? What could we take out there? A 5x. And when you take out a 5x, what do you have in parentheses? So taking out a 5x means dividing by 5x, you have x minus 3. If I do that same thing with the second pair, we have negative 2x plus 6. Jack, what can we take out of negative 2x plus 6? A negative 2. Again, if that term is negative, you're pulling out the negative with it. And then Jack, what do you have left in parentheses? Yeah, so taking out a negative 2 gives us x minus 3. You remember this? So, Ava, what do you notice with the problem? You get the same parentheses. That must be the case for the factoring to work. If the parentheses are not the same, then you didn't pull out the right number, or you didn't pick the right pair of values that add to be the middle number. Is Does anybody remember how to pull this together to get a final answer? Steven?
You have just one of the x minus 3's in parentheses, and the other parentheses is 5x minus 2.
So because 5x and minus 2 are both connected with the same parenthesis, they're considered like terms. You can group them together, so this is called grouping. So I can pull these together in one parenthesis and also pull the x minus 3 together as one parenthesis. Separately, they were multiplied by the x minus 3, so together they're still multiplied by the x minus 3. So this works because if I FOIL, I would have 5x squared. Here's a negative 15x. Here's my negative 2x. And then that plus 6. So it really does work by using this grouping method. But I cannot just simply take those two numbers and say x minus 15 and x minus 2, because that doesn't give me my original problem. Because if I FOIL this, I would get an x squared, a negative 17x, and a positive 30. And I don't have a positive 30 or just an x squared. So this is the AC grouping method. Questions? So it seems like some of you remember seeing that a little bit from last year. Or maybe algebra 1. Maybe last year? Yeah. I think you probably did like maybe a factoring review at some point last year. So if you flip the page, we're just going to work through some problems. The first 3 examples have all positive terms, and then I think the second 3 examples start to flip the positive and the negative. There really isn't a shortcut. Like there's no shortcut around the problem. The only way you can do it is just by like guessing and checking, by just placing numbers in the parentheses and then mentally foiling it. So not a shortcut around it. So you take A times C. Chris, what 2 numbers multiplied to be 14 but add to be 9? 7 and 2. So when you write this, look at your A and C. My A is a 2x squared. My C is a 7. So when I write my 2 numbers next to or in between these values, I want them to work with the numbers that I already have written. So I have a 2x squared. I'm going to write the factor of 2 next, because they have something in common. They both have a 2 in common. And then I would write the 7x with the 7, because again, we're going to be pulling out what they have in common. So I'm placing the numbers in order here, specifically how they work with the number they're paired with. And then I place a little line down the center to show my pieces that I'm grouping together. So Chris, what would you take out of the first 2 pair of numbers? What else besides an x? A 2. So I would take a 2 and an x out, and then that becomes x plus 1. I place the 2 first because they both have a 2 in common. So when I'm grouping them, I can pull out that value they have in common. Chris, what would the second pair have in common then? A 7. So here's the thing that a lot of students kind of miss. You need to put a plus sign here. It needs to be algebraically equivalent to what is before. And if you don't have a plus sign, your problem becomes then multiplication. And it is not total multiplication yet. So if I'm missing this plus sign right here, my problem says 2x times x plus 1 times x plus 1, which is not true. I will mark it wrong. You must have a symbol to still separate to show that it is not a total multiplication problem. I have this first term plus that second group of information. And then after you have it factored a little bit, to pull it together to make it total multiplication is when you pull the 2x and the 7, and then the x plus 1. Questions? If your parentheses aren't the same, don't force them to be the same. That just means you did something wrong. So if these guys are not the same, you did something wrong. You either used the wrong pair of numbers or you pulled out the wrong GCF. So see if you can work through B and C. You can always FOIL to check your work. Just a little mental foiling to make sure that it goes back to the original problem. So when you use those two numbers in between, kind of see how you're placing them. Put them next to the values they would have in common. So I look at my factors and I kind of place them next to the A value that they would have in common, and then the C value. So Gavin, what did you get for letter B?
3x, x plus 1 plus 5.
And then pulling them together, your factored form would be
3x plus 5, x plus 1.
nice. JT, letter C, what would you do?
It was 5x, x plus 2, plus 2, x
Nice. And then our factored form?
5x plus 2, x plus
Excellent. Questions so far? The three problems underneath are only different because now there's a positive and a negative, or the first one has two negatives. Doesn't change the way you factor. It's just when you're looking at those two values that multiply to be -6, one of them is going to be negative. So if I have a negative in there somewhere, then one of those factors is going to have to be negative. So in letter A, we're trying to make a -1. Michael, how could we get a -1 with the numbers that multiply to be -6? 3 and 2. And which one would be negative for us? Yeah, -3. So a -3 and a 2. So when I write those in my kind of expanded form, I'm going to place the -3 first and then the +2. And thinking about grouping the pair of numbers together. So Michael, what would we pull out of the first pair?
3.
And then the second pair?
2x.
Yeah. So 3x plus 2, and then x minus 1. So again, just make sure those parentheses are matching up. Factoring is used to solve so many different types of equations, not just x squared, as we build. So my students in trig and pre-calc right now, we're factoring things in the form of x to the 5th, x to the 6th, and factoring is still involved in that process. Dimitri, if we have negative 20, how would we get two numbers to multiply to be that, but combine to be negative 8?
2 and negative.
Yeah. So placing the 2 with the 4, the negative 10x with the negative 5, what would you pull out, Dimitri?
2x and 2x plus 1 and then negative 5 and 2x plus 1.
Nice.
And now it's simplified to 2x minus 5 and 2x plus 1.
Perfect. Yeah. Any questions with B? So pulling a 2x out of the first pair, a negative 5 out of the second pair, because it's a negative 10x. So if that number, the negative 10, if it's negative, pull out a negative. That way our parentheses stay the same. Peter, how about letter C? We have a negative 18. How do we get a positive 3? Yeah, a negative 3 and a positive 6. So I'm going to place the 6 first, and then the negative 3 next to the 9. Peter, what would we pull out of 2x squared plus 6x?
2x.
And in parentheses, you get? And then out of the second pair, and you also have, nice job. So pulling the terms outside, grouping them, and then x plus 3. Any questions? The last 4 problems are a little different because it's kind of a mix of problems. Because we can't forget about perfect squares. We still will have perfect squares. And it's still a type of factoring. So some of the next 4 problems contain perfect squares. And those patterns that we talked about. So the first part here, it says factor the GCF out first. That is still the question that we need to ask ourselves. What is the GCF? So we have 36x squared minus 16. Is there a GCF that you can pull out of those numbers? And if so, we need to do that first. So Nick, is there a GCF with 36 and 16? What could you pull out? A 4. So before you factor, you need to pull out what they have in common. And we're going to pull out a 4. So Nick, if you pull out a 4, what do you have then?
4 times 4 minus 4.
So then looking inside the parentheses, I see I have a difference, and 9 and 4 are perfect squares. So that means I can still factor it further using the pattern for a difference of perfect squares. Does anybody know how that would factor? Peter? Yeah, so you're square rooting the 9, you're square rooting the 4, and then Peter, how would you write it? Either way, it doesn't matter. 3x plus 2. And then, right. So this is that perfect square pattern. So because it's a binomial, a difference of 2 squares, there's the pattern. You could have a minus first and a plus second. That part doesn't matter. But you need a plus and a minus of the same quantity because I'm taking the square root of them. But I still need to be able to multiply to go back to the original problem. That's why I need to still have those 2 parentheses. So GCF first, and then noticing that they're perfect squares. So looking at the next one, we have 9y squared plus 42y plus 49. So again, first question, is there a GCF? So 9, 42, 49. Is there a GCF, Nina? No, there isn't a GCF. So 42 and 49 have 7 in common. 9 does not. Do they have a 3 in common? No. So there isn't anything that we can do that they would have in common. So then the next step, is there something special about the numbers? So are these special values? They are. Why is 9 special? It's a perfect square. Why is 49 special? It's a perfect square. So this is that perfect square trinomial pattern. And I'm just going to write the pattern above to remind you what it looks like. So if the first number and the last number are perfect squares, 9 is because the square root of 9 becomes 3. 49 is because the square root of 49 is 7. The middle number says if you double 3 and 7, which is 21, if I double that, that makes 42. That's how I get the 42 when I factor it. So I can factor this as 3y, it's a plus sign, plus 7, and then squared. And again, I get the 42 by multiplying 3 times 7 and then doubling that. That's what this little formula means. Take those two numbers, multiply them, and then double those two numbers. So that's the perfect square pattern. I'm going to just have that pattern written above for you. We can write the other one as well with a minus. So looking at letter C, 15p squared plus 24p minus 6. Again, first question, do they have anything in common? So 15, 24, negative 6. Negative 12? Okay. I don't know why I don't have negative 12. There we go. Okay, negative 12. Not negative 6. Jack, do they have anything in common?
3.
A 3? And if you take out the 3, Jack, what do you get?
5p squared plus 8p minus 4.
So after you pull out the 3, what's the next step? How do you proceed? Nick? Yeah, you try and factor it. So we would then look inside and take 5 times negative 4, which is negative 20. So that would be my next step. Nick, are there two numbers that multiply to be negative 20 but combine to be 8? 10 and negative 2? And then what do you do with that? So we're now just continuing the factoring process. So we first took a GCF out, but it doesn't mean we have to stop factoring. So we're going to try and break it down further. Nina? Yes, we are. I'm just going to forget it for now so it doesn't get kind of messed up or kind of shoved in with our current problem. So we'll write it in the final answer. I just omitted, kind of make it a little neater. Nick, what would you take out of the first pair? And that gives us p plus 2, the second pair. And that also is p plus 2. So Nina said, what about that 3? I kind of write the 3 in front as part of my final answer. But I don't write it just so it doesn't get messed up with all the others. So don't forget the 3, and then 5p minus 2p plus 2. So the last one, we have 25t squared minus 110 plus 121. They don't have anything in common, but they are also, Jack?
25 and 121.
Yeah, they're perfect squares. So Jack, how would you factor it? Yeah, it has to be a minus just because this is a minus. So 5t minus 11 in parentheses and then squared. So Monday we'll go through solving these. Same type of factoring, just some solving. Again, do the multiples of 3. Anybody interested in doing 33 or 45? Josh, you'll do 33, Michael 45. Have a fantastic weekend.